All right, let's get through this as quickly as possible. We're stating excluded values, ladies and gentlemen, which means we're doing a lot of this. We're saying, oh, well, there's something divided by something. Well, this can never be 0. It cannot equal 0. So whatever the denominator is, we set that equal to 0 and we see what it can't be. Okay, if that wasn't confusing enough, here we go. Here's the denominator. We're going to set that equal to 0. So we divide both sides by 18. Divide both sides by 18. We have x to the 4th is equal to 0. So when we solve this, we get x is equal to 0 because you take the 4th root of each side. Doesn't really matter if you don't understand what the 4th root is yet. But here's what we got. If you have a variable by itself in the denominator, then we write x cannot equal 0. That is a value that it cannot be. Because then what you'd have here if you plugged it in is 0 divided by 0, and that's something that we can't do. Okay? Over here, another denominator. We set that equal to 0. Guess what? That means x cannot equal 0. All right? If you just have an x there. All right? Same thing here and here. X cannot equal 0 are the restricted values or excluded values for each of those problems. And that's all we're doing. We're not solving anything. We're not simplifying anything. We're just stating the excluded values. Okay. Now, here's where things change. Now I have x plus 8 is my denominator. So I'm going to set that equal to 0 to see what x cannot be. So then if I had x plus 8 is equal to 0, I'm going to subtract 8 from each side. I get x is equal to negative 8. Well, I'm going to turn that x equals negative 8 into x cannot equal negative 8. Because if I were to plug negative 8 in, I would have negative 8 plus 8 here, which would be 0. And I can't take something and divide it by 0. Cannot have a 0 there. So these are my excluded values right there. Now, I'm happy that 6 is here as well because can you set 8 equal to 0? No, that doesn't work. You can't set a number equal to 0. You can set a variable equal to 0. So there are no, was it excluded? Yeah. No excluded values there. X can be anything. All right, moving right along. Now here we have a trinomial. So we're going to set this equal to 0. The first thing we need to do is factor, and then you can do the bubble method, X method with this. Put two numbers multiply to negative 12 and add up to negative 4. That would be negative 6 and 2. So I have k minus 6 and k plus 2. Now, those aren't my restricted values yet because I still now have to set each of those equal to 0. So k minus 6 equals 0. K plus 2 equals 0. So I add 6. I subtract 2. I get k is equal to 6. And I have k is equal to negative 2. Now, that's what k cannot equal. So I just have to put a slash through each of those, box them up, and those are my restricted values. Because if you were to plug 6 or negative 2 back in, you'd be dividing by 0 here, and you can't have that. So those are the excluded values. Same thing on number 8. I'm going to use my bubble method here when I set this equal to 0. Two numbers multiply to 16 and add up to 10. I believe that's 8 and 2. So I'd have n plus 8, n plus 2 equal to 0. So I'm going to set each of those equal to 0. N plus 8 equals 0. N plus 2 equals 0. I'm going to subtract 8, subtract 8, subtract 2, subtract 2. I get n is equal to negative 8, and n is equal to negative 2. I'm going to put a slash through those because that's what n cannot be. N cannot equal those two values. Those are the restricted or excluded values. All right, here in the denominator, I'm going to set that equal to 0, but I'm also going to factor. Now, they have a 6m in common. So when you take a 6m out, you're left with m plus 3. All right, so we're just dealing with the denominator. Haven't even talked about the numerator. Don't care. So now I'm going to set each of these equal to 0 to figure out what my restricted or excluded values are. So here, divide both sides by 6, I get m equals 0. Here I'm going to subtract 3 from both sides. I get m is equal to negative 3. I'm going to put a slash through both of those because those are the restricted or excluded values there. Can't have those. All right. Next up, two numbers multiply to 35, add up to 12. That's going to be 7 and 5. So I would have n plus 5 and then n plus 7 equals 0. So set each of those equal to 0. I get minus 5, minus 7, minus 7. N equals negative 5. N equals negative 7. Okay, I put a slash through those because those are the values that n cannot equal. Can't have them. Can't have them. Okay, moving on. I'm going to factor out a 3b. When you set this equal to 0, I'm going to factor out a 3b. I'm left with b plus 2. So when you set those both equal to 0, 3b equals 0. B plus 2 equals 0. I divide by 3, I get b is equal to 0. I subtract 2, I get b is equal to negative 2. Now I put a slash through both of those because those are the restricted or excluded values there. All right, number 12. Let me change my color a little bit here. 56, got to multiply 56, add up to 15. It's going to be 8 and 7. So it's going to be n plus 8, n plus 7 here. So the denominator equal to 0. Not worried about the numerators here in these cases. So I have n plus 8 equals 0. N plus 7 equals 0. Subtract 8, subtract 8, subtract 7, subtract 7. I have n is equal to negative 8. N is equal to negative 7. But wait! Those are the restricted or excluded values. So we can't be either of those. All right. I have 4 more, and these first 2 are bubble method problems because that's a 7 and you can't simplify it. So that's 7 and 1. I'm going to say 2 and 2, maybe? No, it's going to be the 4 and the 1, I'm pretty sure. So let me do this. 7 and the 1 gives me 7. 1 and the 4 multiplied gives me 4. I'm looking for a negative 3. So I make that 7 negative. That'll work for me. So here are my x's. Hello. Once again, that's because I set this equal to 0. So my 7x pairs up with the negative 1 right there. And then my 1x pairs up with the positive 4. Okay, now that I have that done, I can set each of those equal to 0. Okay, so now we're going to set each of those equal to 0. So 7x plus 4 equals 0. 1x minus 1 equals 0. I'm going to subtract 4. I have 7x equals negative 4. Divide both sides by 7. One of my restricted or excluded values is negative 4/7. So I'm going to go ahead and put the slash through that one. And I add 1 to both sides here. I get x is not equal to 1. So these are my excluded values. Now, over here at number 14, we start the same exact way. I have 7 and 1, but now we're trying to figure out how in the world to get this 64. I'm going to try 8 and 8 because I have a hunch on this one. Now, oddly enough, this is positive, that's negative, so that means both of these are going to have to be negative no matter what. So here we go. 7 and negative 8 gives me negative 56. 1 and negative 8 gives me negative 8. And look at that, it adds up to 64. Negative 64. So I have my 7x pairing up with the negative 8. I have my 1x, or just x, pairing up also with a negative 8. So now that I have that, let me erase those lines now. If you still need them, great. That means you're showing work and not just using photomath. So now I'm going to set this, since we're setting this equal to 0, I'm setting 7x minus 8 equal to 0. I'm setting x minus 8 equal to 0. I'm adding 8 to both sides. So 7x equals 8. Divide both sides by 7. X equals 8/7. However, this is a restricted value. That's one thing that x cannot equal. So then we add 8 to both sides here and here. I get x equals 8, but once again, that's an excluded value. Can't have it. And the last 2 problems, ladies and gentlemen, these are a little nicer. I'm going to go ahead and take a 2 out here because I'm smart like that. X squared plus 11x plus 30. And once again, we're setting these equal to 0, so I'm going to keep factoring the inside. X plus, this is 2 numbers to multiply to 30 and add up to 11. That's going to be 6 and 5, so x plus 6. X plus 5. Glad I took that 2 out. That means we didn't have to use the bubble method. Now, I do have 1, 2, 3 things being multiplied here, but I'm not going to set the 2 equal to 0 because 2 equals 0 doesn't make any sense. All right? So we're just not even going to worry about the 2. We're going to set x plus 6 equal to 0 and x plus 5 equal to 0. Hopefully by now you can do this pretty quickly. Maybe as quickly as I'm doing it. X equals negative 6 and x equals negative 5. But wait, those are excluded values. So put a slash through them and then box them up. Over here on number 16, the last problem, we're going to take out a 5. When we do that, we're left with x squared minus 6x minus 7. Now, since we're setting these equal to 0, we need to figure out two numbers that multiply to a negative 7 and add up to a negative 6. I believe that's negative 7 and a positive 1. So I have my 5, I have my x minus 7, I have my x plus 1. So I'm going to set each of these equal to 0. Not the 5, though, because that's just a number. Can't set a number equal to 0, because it's not. It's 5. It's not 0. So x minus 7 equals 0. X plus 1 equals 0. I add 7 to both sides. Subtract 1 from both sides there. I get x equals 7. X equals negative 1. I put a slash through both of those, box them up, and that, ladies and gentlemen, is the entire assignment. Thanks for working with me.